In this video, we're going to talk about similar triangles and their theories. So the first thing we're going to talk about is mid-segment theorem. Mid-segment theorem, well, first of all, we're talking about a mid-segment, and mid-segments are basically, they're the middle segment. So this XY right here is in the middle of AB and CB. Okay, so what this says is that they're both parallel. That's what this means. Those two lines mean that they're both parallel. So AC is parallel, and you can again see that by the lines there. And then it says XY is half of AC. That's the important part. So basically, if this is 5, I know that this is going to be 10. Now, how did I get that? If you're going from the bigger to the smaller, you're going to divide by 2. If you're going from the smaller to the bigger, you're going to multiply by 2. So again, this is 5, this is 10. If this was 40, I know that this would be 20, so on and so forth. Okay, so we want to find the length of BC. BC is this big thing right here. Well, this mid segment right here is 4.8. So we're going to take that 4.8. We're going to multiply it by 2 to get from the smaller to the bigger. And we would get our answer of 9.6 for BC. Okay. And then YZ, change my color. YZ is right here. Well, AB is right there is 11.5. So we're going to take 11.5. We're going to divide it by 2. And we get our answer of 5.75. That's the mid-segment theorem. Okay, and we're also using similar, so we're using similar figures. Now, similar figures is different from congruent figures because they're not the same, they're proportional. Okay, and when they're proportional, what that means is that we're going to be setting up a lot of ratios, okay? And we're going to be finding scale factor. So this figure below has a scale factor of 2 to 3. So what does this mean? It means that the smaller one is 2/3 of the bigger one. All right? So we're going to set it up as a proportion to solve for x. So 42 goes in the top. Now, why does 40 go to go in the top? Because this segment, or this is smaller than this one. And then x would go in the denominator. Again, to solve this, we're going to cross multiply. So 2x is equal to whatever 42 times 3 is, which is 126. We're going to divide that by 2. And x is equal to 63. So that means that this big one is going to be 63. So this right here, that 2/3, that scale factor, that would be a reduction, okay? Now, why is it a reduction? Because it's less than 1. Okay? Number 5, this scale factor is 6/5. So this is actually going to be an enlargement because it's more than 1. Okay? But let's set up our proportions. So actually x is going to go in the top this time because, again, this is the bigger. And then the 28 would go in the denominator. Multiply. So I'm going to get 5x is equal to 6 times 28 is 168. Okay, we're going to divide that by 5. And I get x to be equal to 33.6. Okay. Okay, now, this right here is a similarity statement. You see how there's just a squiggle instead of an equal sign? This means, again, that they're proportional, not the same, okay? But this helps us set up our proportions. So now, when you guys set up proportions, it doesn't matter how you set it up, but you need to be consistent, okay? So if you start with x over 28, well, x is AB, so AB, it'd be DE, so it would be x is proportional to DE, which is 25. And then BC, again, BC is in the bottom, it would be EF, so 20 would go in the bottom. Again, you're using that similarity statement to help you set up the correct proportions. And then you just cross multiply. So you get 20x is equal to 700 divided by 20. X is equal to 35. Here's another set of proportional triangles. Now this looks like the mid-segment theorem. It's not. Now why is it not the mid-segment theorem? Because DE is not in the middle of this triangle. That's why it's not mid-segment. But, you know, you're setting up those proportions using those side lengths. So what I like to do is I usually just go like top over bottom, top over bottom. So if I do top over bottom, so x over 36 is equal to, now I don't have a top here, but I do know that this whole length is 55. So I'm going to take 55, I'm going to subtract 45, and I get 10. So I know that this top section is going to be 10. So I did top over bottom equals top 10 over bottom, which is 45. Cross multiply, 45 is equal to, 45x is equal to 360. Divide by 45. And I get 8. Okay, same thing here. Left over right. Let's just do 7 over x is equal to left over right. Well, my left is 6. I don't have my right. So I got to take that 27 and subtract 6. So I get 21. So I get 6x equals 147. Divide everything by 6. I get x is equal to 24.5. What you also could have done is you could have done top over bottom. So I could have done 7 over 6 is equal to x over 21. Now, let's look at the similarities here, okay? What I'm looking for is that my diagonals are still congruent, okay? So my diagonals here is 7 and 21. 7 and 21 are diagonals here. 6 and x are diagonals. So we're going to get the same answer no matter what. There's just two different ways of setting up the same problem. This is very similar to what we just did, and I actually love these proportional parts because they're set up for you almost, like it's crazy. So over here we did 45 over 18, top over bottom, 52 over x. For time reasons, I'm not going to solve this, but you could have gone left to right. You could have gone 45 over 52 is equal to 18 over x. Again, the 18 and 52 just need to be diagonal, and the 45 and the x just have to be diagonal. There's a bunch of different ways that you can set these up. Okay, we're all going to get the same answer though. Over here, if I just do 12 over 30 is equal to 14 over x. Again, I could have done 12 over 14 is equal to 30 over x. Whatever your pattern is, just make sure that it's consistent. Same with this. We have an angle bisector, so it's cutting angle B in half. So they did this over this is equal to AB over BC. That's uncomfortable, honestly. I would personally, I always do this. Top over bottom, top over bottom. 12 over 4.8 is equal to 18 over x. If you follow what they were doing up here, you'd get 4.8 over x is equal to 12 over 18. Okay, as you can see, the 12 and the x are still diagonal, and the 4.8 and the 18 are still diagonal. And then you would cross multiply and solve, obviously. Here I'm going to do, oops, wrong pen tool. 40 over 36 is equal to 54 over x. Okay, again, just make sure you're pretty consistent with everything that you do.